Welcome to One Time Success, aka Diligent Tutors. Today's class is the continuation of our last physics class. We will be dealing with system of bodies in a horizontal plane. That is, we are talking about two or more bodies that are placed in an horizontal plane. So you can see an example. We have the body of mass M1 resting on the horizontal plane and the body of mass M2 resting on the horizontal plane. Analysis of the body for the forces acting on them. Let us look at the forces that are acting on the two bodies. Now, for you to analyze the force acting on the two bodies, the first thing to do is to assume the direction of motion. That's the first thing to do. So you have to assume the direction of motion. So we have assumed in this case that the body is what? Is acting down. Now, if the body is acting down, we will be having what? The weight of the body is always down. Either you assume up or down for direction. Weight is always vertically downward. So the weight of this body M2 is what? Is M2G. Now, tension is always directed towards a fixed point. Now, if you consider the body of mass M2, the tension is fixed at what? The body of mass M1. That's where the tension is fixed. So, if you are considering the body of mass M2, the tension will be directed toward the body of what? Mass M1. Then, if you are considering the body of mass M1, the tension will be directed towards the body of what? Mass M2. So, in the first body, the body of mass M2, we have the tension going towards the fixed point, which is upward, and the weight acting downward, which is what? M2G. Now, if you look at the body of mass M1, the tension is towards the body of mass M2, and the frictional force opposes what? Motion. So these are the forces acting on the system. Don't forget that for a body in an horizontal plane, the normal reaction is what? M1G, and the frictional force is mu R, which is mu M1G. Now let's look at the acceleration of such body, the acceleration of a body on an inclined plane, that acceleration of the system of a body in an inclined plane. Now let's look at the first body, which is what? The M2 and also what? M1. For the M2 body, M2, we have the weight acting downward, W, minus the tension opposing the motion. That will give me what? The resultant force with which the system moves. Don't forget that we have assumed the system is moving downward. So what do we have there? We have M2G, which is the weight, minus the tension is what? M2A, the resultant force. If you make the tension the subject of the formula, we are going to be having what? M2G minus M2A. Let's call this one equation 1. Now, for the M1 body, the whole system is moving down. So, tension is moving the body, frictional force is opposing the motion, and that will give us what? The resultant force. So, if we substitute into that, we will have tension minus mu M1G, which is the frictional force, is equals to M1A. So tension is what? M1A plus mu M1G. And let's call this one equation 2. Now tension on the same string is equal. So equation 1 is equal to equation 2. Equation 1 is what? M2G minus M2A is equals to M1A plus mu M1G. Now let's collect like terms. Let's bring the acceleration together. So we have M2G minus mu M1G is equals to M1A plus M2A. So that will give me A into M1 plus M2. That will be equals to M2G minus mu M1G. So the acceleration of the system will be M2G minus mu M1G over M1 plus M2. Now, don't forget that if the horizontal plane is smooth, mu will be equals to 0. So the acceleration will be now M2G over M1 plus what? M2. Now, equation 3 is for a body on a rough inclined plane, and equation 4 is for a system of bodies on a smooth horizontal plane. Sorry, horizontal plane, not inclined plane. Now let's take example. Find the acceleration of the system of bodies shown below if the coefficient of static friction is 0.5. So the first thing we are going to do, let us assume our direction. Let's assume the system is moving down. Now the weight is always downward. W will be 4 times 10, and that will give me 40 Newton. Now, for this body, the weight is 2 times 10, and that will be 20 Newton. Now, tension is moving upward here. Tension is moving here. Then frictional force is opposing the motion. So let's start for the 4 kg body. For the 4 kg body. Now we are going to have weight, which is what? 40 Newton minus tension is equal to the resultant force with which the body moves, which is 4A. Now T will be 40 minus 4A. 40 minus 4A. 40 minus 4A. Let's call this one equation 1. Now for the 2 kg body, we have that tension minus frictional force is equals to MA. So tension minus frictional force, which is what? Mu mg equals to MA. So that will be T minus 0.5 times mass, which is 2, times G, let's take G to be 10, will be 2A. So that will be T minus 10. 0.5 times 2 times 10 is 10, is equals to 2A. So T is 2A plus 10, equation 2. Now, equation 1 and 2 are equal because tension on the same string are equal. So what do we have there? Equation 1, 40 minus 4A is 2A plus 10. So let's collect like terms. 40 minus 10 is 2A plus 4A. 4A, take note, this is A. So we have 30 is equals to 6A. So divide both sides by 6, A is equals to 5 meter per second squared. Now let's look at another example. Let's look at another example. Let's look at another example. Example 10. Now, find the acceleration of the system of bodies shown below if the horizontal plane is smooth. Smooth means there is no what? Frictional force. So the first thing we are going to do here is to assume our direction of motion. Let's assume that the body is moving down. Now, let's start here. The weight of the body will be 200 Newton. That is 10 times 20. The tension on the body will move up. The tension here will go like this, and we will have the frictional force there. So for the 20 kg body, we will have weight minus T is equals to MA. So what is the weight? 200 minus T is 20A. So T will be 200 minus 20A. So that will give me equation 1. Now for the 40 kg body, we are going to have tension minus frictional force is equals to MA. Frictional force is 0 because plane is smooth. Is equals to 40A. So T is 40A. Now this is equation what? 2. Equation 1 is equal to what? Equation 2. What is equation 1? 200 minus 20A is equals to 40A. Now collect like terms. 200 is equals to 40A plus 20A. So we have 200 is equals to 60A. So A will be 200 over 60. That will give me 20 over 6, which is 10 over 3. That will be 3.3 meter per second square. Now let's look at another example. We solved this question before. Okay, no, we've not solved this question. This is 3 kg and 5 kg. So the first thing we are going to do, assume direction of motion. So we're assuming they are coming down. So the weight here, W for this body, what will it be? That will be 5 times 10, that's 15 Newton. Now we are using 10 for G in this question. Yours might be 9.8. So T, we have frictional force. So let's go for the 5 kg body. We will have weight minus tension is equals to MA. So that will be 50 minus T is equal to 5A. So T will be 50 minus 5A, equation 1. Now for the 3 kg body, 3 kg, we will be having tension minus frictional force is equal to MA. So that will be tension minus mu M1 G is equals to MA. So that will give me tension minus what is mu? 0.5 times M1, which is 3 times 10 equals to 3A. So T minus 0.5 times 10 is 5. Then times 3, that is 15 is equals to 3A. So T will be 3A plus what? Plus 15, equation 2. Equation 1 and 2 are equal. So I'm going to have equation 1. 50 minus 5a is equals to 3a plus 15. Let's collect like them. 50 minus 15 is equals to 3a plus 5a. So that will give me 35 is equals to 8a. So in that case, a will be 35 over 8 meter per second square. So that is the acceleration of that system. Now let's look at normal reaction of a body on an inclined plane. When a body is placed on an inclined plane, we will be having the normal reaction perpendicular to the plane, but the weight of the object will be inclined at an angle that is equal to the angle of the plane. So theta is the angle between the plane and the horizontal, and beta is the angle between the plane and the what? And the vertical. So because the weight of the body is inclined at an angle, we will have to resolve what? That weight. Now, the angle between the plane and the horizontal theta plus the angle between the plane and the vertical will be equal to what? 90 degrees. Note that we are working with the angle between the plane and the what? And the horizontal. Now, let's look at the resolution of the weight. If we resolve the weight, the adjacent will be W cos theta, the opposite will be what? W sin theta. So if we take and place the forces appropriately, we will have W cos theta acting downward, while normal reaction acting what? Upward. The frictional force will oppose the motion because a body that is placed on an horizontal plane has a natural tendency to move down. So we have W sin theta as the force moving that plane, moving the body down. So frictional force will oppose the motion. Now, let's look at a few examples. A body of weight W Newton rests on a smooth plane inclined at angle theta to the horizontal. What is the resolved part of the weight in Newton along the plane? The resolved part of the weight in Newton along the plane is always what? mg sin theta. mg sin theta is the what? Is the resolved what? Part of the weight along the plane. Now, let's look at conditions for calculations. What are the conditions for calculations? Now, if the body, we have resolved the weight, we have placed all the forces in the right order, frictional force is acting upward, W sin theta, which is the force that's always act downward. That's the reason anybody placed in an horizontal plane tends to move down naturally because of what? W sin theta. So in this case, the normal reaction is what? W cos theta, which is mg cos theta. Frictional force, which is mu r, is mu mg cos theta. Now, if the body is about to move, that is showing a tendency for what? For motion, the force moving it down will be equal to the force opposing the motion. So we can say frictional force will be equal to what? W sin theta, which is what? Mg sin theta. But frictional force is what? Mu mg cos theta. Mu mg cos theta. So mu mg cos theta is equals to mg sin theta. So we can say mg go with what? Mg. We have sin theta over cos theta. Sin theta over cos theta is what? Is tan theta. That's the first condition. Now, this condition is also true if the body comes to rest.